You know, there's this vast, invisible force field protecting us every single second of every day. It's the only thing standing between all of us and the, frankly, hostile environment of space. So let's dive into what this incredible shield is all about and, what makes life on Earth even possible.
Okay, so to really get this, we have to start with the threat. And that threat is the sun. Now don't get me wrong, we love the sun, but it's not just sending us light and heat. It's constantly firing this stream of charged particles at us. We call it the solar wind, and it's moving at nearly 1,000,000 miles an hour. It is a relentless, non-stop cosmic storm headed right for us.
And this really puts the stakes into perspective, right? You've got Earth on one side, all cozy with its thick, life-sustaining atmosphere, and then you have Mars, a barren, cold, dead world. And why? Well, the prevailing theory is that the solar wind literally stripped Mars's atmosphere away after its own shield failed billions of years ago.
So that begs the big question, right? What makes us so different? Why did we survive when our neighbor became this desolate wasteland? What's our secret weapon?
Well, here's the answer. Earth has an unseen shield. It's our planet's magnetic field. It's this massive, powerful, and completely invisible force field that wraps around the entire globe.
So this magnetic field carves out a safe zone in space, a region we call the Magnetosphere. And you can absolutely think of it like Earth's personal force field. Its main job? To bat away that constant barrage of solar wind and all sorts of other nasty cosmic radiation. It makes sure that stuff never even gets close to the surface.
But here's the cool part. It's not a perfect sphere, not even close. The solar wind is always pushing on it, so it gets squished on the side facing the sun, and then on the night side, it gets stretched way out into this enormous tail. It looks kind of like a giant comet, stretching for hundreds of thousands of miles into space.
And nestled inside this bigger shield, you find these incredible things called the Van Allen belts. Picture two giant, invisible, radioactive donuts circling the Earth. They're full of high-energy particles that our magnetic field has trapped. They're like a second line of defense, snagging any dangerous radiation that might sneak past the main shield.
And you really can't overstate how important these belts are. I mean, it's not just about protecting us, people. This quote really nails it. They are absolutely critical for protecting our technology, our satellites, GPS, communication systems, power grids, basically our entire modern world from getting totally fried by this radiation.
Okay, so where does this planetary superpower even come from? Well, to figure that out, we have to take a little trip, thousands of kilometers straight down, right into the heart of the Earth.
Because this is where you'll find the engine of our shield. It's Earth's outer core, a giant swirling sea of molten iron and nickel. And when I say hot, I mean hotter than the surface of the sun. This is where all the action is.
So how do you build a planetary magnet? Well, it's a process called the geodynamo, and it's kind of like this. First, you've got the super hot, solid inner core heating up the liquid outer core around it. This makes that liquid iron churn and boil, kind of like water in a pot. Then, you add the Earth's spin, which twists all that churning liquid into these giant swirling whirlpools. All that moving, molten metal generates massive electrical currents. And here's the payoff. Moving electric currents create a magnetic field. In this case, a magnetic field big enough to shield an entire planet. Pretty amazing.
Okay, so we have this amazing shield, but it's not invincible. It's got cracks in its armor, and it can be totally overwhelmed by some of the most violent storms our solar system can throw at us.
Every so often, the sun does more than just blow its usual solar wind. It unleashes these colossal explosions of energy and plasma called coronal mass ejections, or CMEs. And if one of those is pointed at Earth, well, it's like a cosmic hurricane slamming head-on into our defenses. And that collision triggers what we call a geomagnetic storm.
And these aren't just some abstract space weather events. They have serious, real-world consequences. Back in 1859, the Carrington event was so intense, it actually set telegraph systems on fire. More recently, in 1989, a storm knocked out power for 6 million people in Quebec. And just this year, in 2024, a big storm caused what was basically one of the largest satellite traffic jams in history, with operators scrambling to move their spacecraft out of harm's way.
So what would happen if a storm like that Carrington event hit us today? The stakes are just staggeringly high. We're talking about a potential cost of up to $2 trillion in damage. That's trillion with a T. It would be a catastrophe for our modern world.
So on top of solar storms, our shield has this weird, persistent weak spot. It's called the South Atlantic Anomaly. It's this growing area, mostly over South America and the Southern Atlantic, where the magnetic field is just weaker. And because it's weaker, that inner Van Allen radiation belt actually dips down closer to Earth. This is a huge problem for satellites, like the Hubble telescope. When they fly through this region, they get blasted with so much radiation that they actually have to shut down their sensitive instruments to keep from being damaged. All right, so let's bring this all back home. What does this magnetic field mean for our future and for our day-to-day lives?
I mean, it is just incredible how much this thing does for us every single day without us even thinking about it. It deflects the solar wind, sure, but that's what preserves our atmosphere and our ozone layer. It traps that dangerous radiation. It's even the reason the compass on your phone works. And, as a little bonus, it gives us one of the most stunning shows on Earth, the aurora.
And it goes way beyond just us and our tech. For so many animals, the magnetic field is basically a sixth sense. It's called magnetoreception.
We're talking birds, sharks, sea turtles. They use this field as a built-in global GPS to navigate the entire planet. It's just mind-blowing.
But here's the thing. This shield isn't static. It's always changing. For instance, over the last couple of centuries, its overall strength has dropped by about 9%. And at the same time, the magnetic North Pole isn't staying put. It's been wandering. And in recent years, it's picked up speed, racing away from Canada and heading towards Siberia.
Now, before you panic, scientists are pretty clear that this doesn't mean a full-on magnetic pole flip is about to happen tomorrow. But it is a really powerful reminder that our shield isn't some fixed, unchanging thing. It's a living, breathing, dynamic system. It's constantly evolving.
And all of that leaves us with one last, really big question. This invisible shield has been our planet's guardian for billions of years, and it's always changing. Figuring out what it's doing isn't just for scientists in a lab. It's absolutely key to our future. So, the question is, are we ready for whatever it does next?